fellow biologists, today we are going to go through the bubble lab. Unfortunately, in our circumstances, we're not going to be able to play with bubbles in a class as a whole, but it's really important for us to use bubbles, something that most of us are familiar with, as a great model to what the cell membrane is like. And so I'm going to walk through the 5 cell membrane concepts that we're going to look at using bubbles. The first cell concept states that membranes are fluid and flexible, that cell membranes are not static, and that they bend, they flex in order to adapt to the changing environments. And so we're going to use bubble solution, and I have made a square wand. I'm going to go ahead and put my wand into, and you can see that I have created a bubble. And what I'm going to do to demonstrate, illustrate that cell membranes are like bubbles, that they are fluid and flexible, I'm just going to move this slightly, do it again, move it slightly up and down, and you can see, if I can keep the bubble long enough, sometimes that happens. Luckily your cells aren't constantly breaking, but as I gently move this up and down, you can see that the bubble is very flexible. It moves with the force that I'm applying to it. It changes shape, and it's very fluid. Like your cell membrane is constantly changing shape. It is fluid, it is flexible, and it will move. So go ahead and pause the video at this point and put the cell concept into your own words, and then describe what you saw in the bubble and how that applies to a cell membrane. Okay. All right, coming back. Cell concept 2. Membranes can self-repair. And so that's really important for your cell membrane. If it were to tear or to break like our bubbles were breaking, it's really important that they can self-repair. So the attraction, that connection between those phospholipids, allow cell membranes to repair small openings. And so what we're going to do is I'm going to create a bubble. So I have a bubble here. You guys can kind of see it. And then what I'm going to do is I'm going to actually go ahead, and the bubble is still there if you can see it, and I'm going to put my hand through it, and I'm going to pull my hand back, and I still have, the bubble was still intact while I did that. And so you can see the bubble is here. I'll move it a little bit so you can see it. I'm going to put my hand in. That time it broke, unfortunately. I can put my hand into it. I can pull it back, and we still have our bubble intact. It's very important that our cell membranes, like bubbles, can self-repair, meaning they can fix themselves as long as what's moving through them is similar substance. For example, I had to put my hand in the bubble solution in order to move it through the cell membrane. Go ahead and stop the video and complete cell concept number 2. Membranes can self-repair. Cell concept number 3. Eukaryotic cells feature membrane-bound organelles. Membrane-bound organelles are basically the organelles, so the nucleus, the mitochondria, the chloroplasts, the vacuoles, all of those tiny structures inside a cell also have their own membrane, and it is also lipid-based. And so in order to understand that and to see how that works, I'm going to take a straw that's clean, and I'm going to go ahead, and hopefully we can see this here. I'm going to create a bubble inside the tub. All right, so I have a bubble that's created, Now, what I'm able to do is I'm able to blow a bubble inside of this bubble. And so that will represent an organelle with its own membrane existing inside a cell with its cell membrane. Now notice, what did the bubble want to do immediately? If you can see that, as I'm blowing a bubble inside the bubble, the bubble inside is wanting to move and move right outside the cell membrane. Now that would be a problem if your nucleus wanted to connect to your cell membrane and then push out. The difference between the bubble I blow and your cell is that in this bubble, what's on the inside of the bubble? It's just air. There's nothing holding it in place. This is a really important indication as to why cytoplasm is so important to hold the organelles in place, to not allow the organelles membrane to connect with the cell membrane. Because when that happens, it literally can move from the inside to the outside of the cell. That's actually how the Golgi body will package proteins in vesicles and will send them. They have their own little membrane, will actually send them out of the cell. That's how that happens. I'll try one more time. So here I have my cell membrane. If I go inside, cell concept 4, membrane proteins perform special functions. And so in the cell membrane, it is primarily made up of phospholipids, a bilayer. In that bilayer phospholipids, you'll have some cholesterol to keep it fluid. You will also have proteins, and there can be integral proteins, those that go all the way through, that open and provide channels or doors for things to move from in and out to in. And then you also have proteins that are just peripheral. They're sitting on the outsides. For example, when you become vaccinated, you gain new proteins that sit on the outside of your cells, so your body can learn how to fight off a specific virus with certain proteins. So cell concept number 4, what we're going to do is we're going to show you how we can create openings within cell membranes, and the cell membrane stays intact, but there can be a small opening there. And so what I'm going to do is I have a small piece of string. This one sometimes requires a few times, but I'm going to take my bubble and I'm going to attempt to put this string onto, and then what I'm going to do is I'm actually going to pop the middle. And then the whole thing popped because it's real science, and it's not the cell membrane, thank goodness. That's not how it really works. And this is just a model. So we'll try it again. It's a little bit heavy. We'll go ahead and pop the inside of it, and now you can see that as that moved around, it acted as a hole in the middle of the membrane, and that hole could move. So it's not like it was stationary in one place, like the door in my room. I can't move the door doesn't move. When you come every day, it's in the same spot. A integral protein is an opening into the cell. However, notice that it's constantly moving, and so it's fluid, it's flexible, it's mobile. And so that opening can exist, and the membrane can stay intact all around that opening if it's a protein. So it acts as a barrier like the string, and it acts as a channel for things to move in and out, allowing a cell membrane to do its job at regulating what gets in and what gets out of a cell. Go ahead and pause the video and complete cell concept number 4. Membrane proteins perform special functions. Okay, the last cell concept that we have is cell concept 5. Cells reproduce through binary fission. What this means is that a single-celled organism, one cell, can actually reproduce by splitting into 2 cells. And how we're going to show that is I'm going to create a bubble. All right, so there I have a cell. It's my cell membrane. I am literally able to take the straw, if it has soap on it, of course, and as I apply a force right down the middle, if I can do it quick enough, I just divided it into 2 cells. Both of those cells pop. We don't want that to happen. However, by taking a cell membrane and pinching it together or applying force, when the cell membrane comes close enough, it will combine with itself and it will actually divide that cell into 2. That is how cells undergo binary fission, which is how they reproduce. Part of the cell theory is cells come from pre-existing cells. If you have a cell, that cell will go through its cycle. It'll make a copy of all of the material inside, especially the chromosomes, the DNA in its nucleus, and then it will undergo a process known as cytokinesis, where the cytoplasm breaks into 2, literally by pinching inward and becoming 2 cells. I'll go ahead and show you again. That one started off as many cells, but even as I just run this through, now I'm breaking it. And so when you were a one-celled organism, your one cell started to replicate, and it would become 2 cells, and then 4 cells, and so on and so forth. And so cell concept 5, cells reproduce through binary fission. That's literally just dividing from 1 into 2 after it has made a copy of all of the important material inside. Go ahead and stop the video and complete cell concept 5. Hope this is helpful. If you have questions, please reach out to me and ask, and I am happy to help.